Welcome back, everyone. So now we are going to start with our question number 11. So in the last video, we have covered till question number 10. So let's cover a few more questions as a part of this particular official practice exam. I'll go to continue. So number 11 is a company is building an application to track the athlete's performance using an Amazon DynamoDB table has already been created. And each item in the table is identified by the partition key, user ID, and the sort key sports name. The table design is as shown below. Partition key is user ID, sort key sports name. Attributes are score, date, time. Okay. You can relate items with the rows and attributes with the column for the better understanding. A developer is asked to write a leaderboard application to display the top performer's user ID based on the score for each sports name. Okay. So now the user wants to display the list of top performers based on the score for each sport name. Okay. So if you're aware about the concept of indexes in the DynamoDB, you would be knowing that there are two types of indexes, global secondary index and local secondary index. Okay. So global secondary index basically is a type of index where you have a partition key and sort key, which would be different from the base table. And the concept behind creating indexes in the DynamoDB table is again to improve performance if you want to query on the non-primary key attributes. Okay, so when we are saying that we have to list or display the top performers based on the score. So score is a non-primary key attribute. Okay, let's read the option. It's a straightforward question. Use a DynamoDB query operation with the key attributes of user ID and sports name and the order the results based on the score attribute. That is option A. Option B is create a global secondary index with a partition key of sport name and a sort key of score and get the result. Option C, use a DynamoDB scan operation to retrieve scores and user underscore ID based on sports name and order the results based on the score attribute. And if we'll move towards option D, it says create a local secondary index with a primary key of sport name and sort key of score and get the results based on the score attribute. Now, one thing, table is already created and you can't create a local secondary index after the creation of a table. So option D would be removed straightforward. Now, when it is talking about querying on the basis of primary key attribute, and I gave you the hint that was indexes. So there were two options with respect to the index description. I have removed option D. What is left in front of you? B is left. Let's choose it. So B is the correct answer. You can read about it from here. You can say that a global secondary index efficiently retrieves the leaderboard. You can create a global secondary index named leaderboard with a partition key of sports name and sort key of score. The base table's primary key attributes are always projected into an index so that user ID attribute is also present. Additionally, you can create a global secondary index after the table is already created. Okay. At the same point of time, if you want to read D, you can see that local secondary indexes on the table are created only when the table is created. As we have a table already created, a local secondary index can't be created. So B would be the correct option. Okay. A developer needs to create a serverless application that uses an event-driven architecture. What should the developer do to implement the application's ability to receive and process events? Okay. It is saying event-driven. Let's read the option. Create an Amazon simple queue service. Publish events to the queue. Create an SQS consumer to an EC2 instance that polls for the new message. As soon as EC2 came here, this is not applicable serverless, so remove A straightforward. Again, in the option B also EC2 is there, so you can remove B2, okay? If you talk about option C and D, in option C it is saying that create an Amazon simple notification service topic. Create a Lambda function, subscribe the Lambda function to the SNS topic, submits the event to the SNS topic. Create a REST Amazon API gateway, create an AWS Lambda function, call the API endpoint. It is saying event-driven architecture. Event-driven architecture means when there would be an event, the event should be trigger your function code. So C is looking suitable as per the question requirement, where we are going to create an SNS topic, and this SNS topic will use a push-based notification to trigger a Lambda function. Okay, and Lambda is an event-driven serverless compute service. Let's see that. C is the correct one. Now, if you will compare it with D, you can see that in D, if you invoke the Lambda function through the API gateway endpoint, the action does not fulfill the requirement to be event-driven. It's a direct call. We have push-based invocation, we have pull-based invocation, we have direct invocation. It is talking about the event-driven architecture. So D would be eliminated. Okay. A company hosts a web application that writes to an Amazon DynamoDB table. Application users frequently observe and report errors. The development team examines Amazon CloudWatch logs and frequently sees the following error. 400 bad request provision throughput exceeded exception. Okay. What could be the possible answers for this particular question? The application doesn't have the required permission for the DynamoDB table. Okay. The item that the application is placing on the table exceeds the item size limit. The development team has not allocated enough space for the table and its indexes. The development team has not allocated enough write capacity unit for the table and indexes. It is saying throughput exceeded exception, provision throughput exceeded exception. So whenever we are basically provisioning the throughput, we have two options. Either we can go for the provision throughput or the on demand. Okay. So here we are basically provisioning the read capacity unit and write capacity unit. And the question is saying that a company hosts a web application that writes to the DynamoDB table. So these are the frequent errors which are getting into picture when a company hosts an application that writes to the DynamoDB table. So let's choose option D and let's see what's the correct one. So D is the correct one. You can see why other options are not correct. Option A, provision throughput exceeded exception error indicates that the maximum allowed provision throughput for a table or for one or more global secondary indexes has been exceeded. A permission error would return a different error code. Okay. The item that the application is placing on the table exceeded the size limit. So an attempt to call the put item operation that exceeds the maximum item size limit would result in a validation exception error, not a provision throughput exceeded exception error. Okay. Option C, there is no practical limit on a table size. Tables are not constrained by the number of items or the number of bytes. Okay, so C is not valid. And D, which is correct, a provision throughput exceeded exception error indicates that the maximum allowed provision throughput for a table or for one or more global secondary indexes has been exceeded. So D would be the correct choice. Okay. A development team uses AWS code build for build and test activities in a PHP application. The build process requires the team to download and install 3 PHP packages from the internet. The install section of the build spec YAML file includes commands to download and install these 3 packages. The team wants to reduce the build time. Which solution will reduce the build time most? Download the package files from the internet, upload the package file into an Amazon S3 bucket, change the build specs install section to use the S3 bucket as a download location. Define a VPC endpoint for code build, install the package files on EC2 instance in the VPC, change the build specs install section to use the EC2 instance as a download location. Option C, create a custom code build image with the package files already downloaded and installed. Alter the code build project to use the custom image, remove the install command from the build spec. Option D, run the build on Jenkins by using the Jenkins plugin for code build. Pre-install the packages on the Jenkins server. Once, remove the install commands from the build spec. It's again talking about reducing the build time. Option C is saying create a custom code build image with the packages files already downloaded and installed. Means our packages file are already a part of a custom image. So it will reduce or it will eliminate the download time, which is basically going to reduce the build time. Let's see this. It's correct. You can read it. A custom code build image is a Docker image that you create with everything you need to build and test a project. When a developer builds the application, code build will retrieve the Docker image from the container registry that the project configuration specifies. Code build will use the environment to compile source code, run test, and package an application. There is no need to download the packages from anywhere upon each build. This solution greatly reduces the build time, and that was our requirement. Okay. A development team is migrating a monolithic application to Amazon API Gateway with AWS Lambda integrations using the AWS CLI. The .zip deployment package exceeds the Lambda direct upload deployment package size limit. How should the Lambda function be deployed? Okay. It is talking about the deployment of a Lambda function, and the point is .zip deployment package exceeds the Lambda direct upload deployment package size limit. So if you've ever tried, in order to upload a Lambda function from your local machine, there is an option. If the package size exceeding the direct upload deployment limit, you can upload the package in the S3 bucket, and from there you can refer it. Now find the option which is talking about the S3 bucket. So let's read all the options first. Option A, use the .zip file to create a Lambda layer and reference it using the --code CLI parameter. Create a Docker image and reference the image using the --docker-image CLI parameter. Upload a Docker package using the -zip-file CLI parameter. And finally, upload a deployment package to Amazon S3 and reference S3 using --code CLI parameter. Let's choose this one. And it's correct. You can read about it. Why D is correct? You can use Amazon S3 to circumvent the 50 MB deployment package size limit. The S3 upload method provides a documented best practice workaround for the 50 MB file size quota. Okay. A company is developing a global website in EC2 to track flights. The website will use an Amazon RDS database to store flight position and speed information. A developer needs to ensure that application can securely connect to the database by using the database credential. The developer also needs to set up automatic rotation of those credentials. Now, the two keywords is developer wants to securely connect to the database by using database credential, and developer also needs to set up the automatic rotation. Whenever these keywords comes into picture, straightforward move towards AWS Secret Manager. Okay. If you want to read about AWS Secret Manager, you can always open the user guide. Let me help you out. You can see this. What is AWS Secret Manager? This is an intro page for the AWS Secret Manager. You can see it helps you manage, retrieve, and rotate database credentials, application credentials, OAuth tokens, API keys, and other secrets throughout the life cycle. Rotation is there, and it is managing and retrieving database credentials. If I will go back to my question, that is a requirement of my question. You can read all other options. In the first option, it's asking you to use the certificate manager to issue an X.509 certificate. And then it is asking you to configure the application to use this certificate to connect to the database. Okay. This is the additional configuration, or this is the extra work it's asking us to do when we have a direct solution available with us. Use the system manager parameter store to store the database credentials. Configure the application to use the parameter store to retrieve the database credentials. Set up the automatic secret rotation. Now, you can also check secret manager versus system parameter store. That also you can check. System manager parameter store. If you want to get the differences. Okay. Let's try one more time. Secret manager versus system manager parameter store. And press enter. Okay. You can read about it. If you want, you can open the AWS official documentation and you can see the differences. Okay. You can see parameter store is used by DevOps to store configuration data such as IP addresses. It can store secrets in an encrypted or unencrypted fashion. Secret manager is used by IT and security administrators to manage the lifestyle of secrets such as database credentials. It allows multiple versions of the secrets to exist in the same time when performing a secret rotation. Key differences between two services includes cost and use cases. Secret manager is paid while parameter store is free. Choose secret manager if you want to store only encrypted values and need an easy way to manage the rotation of the secrets. Okay. Come back, choose this option, which is talking about a secret manager, and say confirm. And you can see it's the correct one. You can see the point 4b, parameter store does not support automatic rotation of credentials. And that was our requirement, one of the requirements. Okay. And option D, secret manager can store and distribute credentials programmatically from a central and secure data store. Secret manager can also automatically rotate the secrets according to a specified schedule. Okay. Number 17, a developer has launched an application that calls an API by the way of Amazon API Gateway. It offers information that changes several times a day, but is not updated in real time. The application has become so popular that the API endpoint is overloaded and the traffic to the endpoint must be reduced. What can the developer do to address the performance issues? Here it is talking about the performance issues. So we have a concept of API caching at API gateway. So we can use API caching in API gateway. Let's see other options too. Enable API caching in Amazon Elastic Cache. Elastic Cache is an in-memory data store. Okay. Enable an auto-scaling group on the endpoint service and database, and create an additional API gateway and use an application load balancer. Let's see this. It's a correct one. API caching in the API gateway improves the performance by reducing the number of requests that are sent to your endpoint service. Okay. A development team uses an Amazon DynamoDB table as a part of a data collection project. The average table item is 7 kilobytes in size. The table experiences no more than 100 reads and 50 writes each second. The table has no local secondary indexes. Eventually, consistent reads are acceptable. What are the minimum acceptable values for the tables RCU and WC? Read capacity unit and write capacity unit. So if you are aware about the definition of read capacity unit and write capacity unit, you would be able to answer it. So 1 RCU is equals to twice the number of eventually consistent read per second for the data size of 4 KB in size. Okay. And 1 WCU is equals to number of strongly consistent write operations you are performing per second for a data size of 1 KB in size. Okay. So now if you're aware about these definitions, you will be able to do a calculation very easily. Let's try that. I have 4 options: 100 RCU and 350 WCU, 200 RCU and 350 WCU, 700 RCU and 350 WCU, 700 RCU and 700 WCU. Let's see the calculation. Let's try with this one. And it is correct. You can see each RCU can read up to 4 KB on a strongly consistent basis. Each 7 KB that requires a 2 RCU for each read, round 7 up to the next multiple of 4 and then divide by 4 equals to 2. Means the formula is, if you want to calculate, you can simply use the definition 1 RCU equals to twice the number of strongly consistent read you can perform per second for the data size of 4 kilobytes in size. Okay. Or you can say 2 times the eventually consistent read you are performing per second for a data size of 4 KB in size. Okay. And when you talk about WCU, you can see each WCU can write up to 1 KB. Okay. Each 7 KB item requires 7 WCU for each write. 50 such items into 7 equals to 350 WCU. Okay. Let me write a formula one more time. It is this. You will be able to calculate from here. 1 RCU equals to 1 strongly consistent read per second for data size of 4 KB. And it is also equivalent to 2 eventually consistent read okay, for a data size of 4K. And one WCU equals to number of write operations per second for data size of 1 kilobyte. Okay, based on this definition, you will be able to calculate the number of RCU and number of WC. Okay. Let me write this here. Please allow me a minute. I can write it here one more time. One RCU equals to one strongly consistent read per second for data size of 4K. Okay. It is also equivalent to two eventually consistent read. Now, how to calculate it? You have a table item of 7 KB in size. So first of all, divide this 7 KB by 4 KB. Okay. It will give you something like 1.75. You have to round it off to the next number that will give you 2. This is the next number. Okay. Now, it is asking that the table experiences no more than 100 read and 50 writes each second. Okay. So now use a formula. 2 eventually consistent read, okay, equals to 1 RCU. So 100 read will be equals to 1 into 100 divided by 2, mathematical formula 50. Okay. And now multiply it with the rounded off number you have got. So 50 into 2 will give you 100. Okay. And that was our option. Similarly, you can do it for the WC. Okay. So one WCU is basically equals to number of write per second for the data size of 1 kilobyte. Okay. Using this formula, you can calculate it. Let's move back. Next question, a company is designing a public upload platform on Amazon S3. Anyone should be able to upload data that is encrypted with the public key. Only the company should be able to decrypt the uploaded data. The company needs to use an asymmetric encryption key for this functionality. Which feature can the company use to directly meet this requirement? Server-side encryption with the customer-provided encryption key, server-side encryption with the AWS KMS managed encryption keys, client-side encryption with the customer-managed encryption keys, and client-side encryption with the SV managed encryption key. It is saying that a company is designing a public upload platform on S3. Anyone should be able to upload the data that is encrypted with the public key. Means data should be encrypted with the public key before you're uploading it. I am managing the encryption at a client side. Okay. The company needs to use an asymmetric encryption key for the functionality. Let's try with this one. And it's correct. You can see. Why other options are not correct? SSCC, server-side encryption customer managed key, supports the use of symmetric keys. It does not support asymmetric. Asymmetric is another keyword here. Server-side encryption with the KMS. You can use KMS to get an asymmetric key. However, SSC KMS supports symmetric keys, not asymmetric keys. Okay. Client-side encryption with customer managed encryption keys allow users to select either symmetric or asymmetric, means we have the options. And the last one, S3 managed encryption keys are symmetric. You can use these keys only for server-side encryption, misleading. Okay, so C is a correct one. A company stores the photographs in an Amazon S3 bucket. The company wants to resize the photographs automatically after writing the photograph to the S3 bucket. The company creates an AWS Lambda function to resize the photograph. Which solution will meet this requirement? Now, if you're aware about S3 features, in S3, we have a concept of event notification. The name itself is suggesting notifying about the event. Whenever there will be an event in the S3, you can call the destination services, which can be Lambda function, SNS topic, SQS queue, or an event bridge. So here it is saying that as soon as the photograph will be written to the S3 bucket, you want to resize it. Okay, so there would be a put event which you are performing. Obviously, if you are using some form, that could be a post event. So you can choose the event accordingly, but the feature which will come into picture, that is event notification. Okay, let's choose this. And this is the correct answer. Okay, we can also reach other options. Configure an S3 lifecycle rule to invoke the Lambda function. That's not true. Lifecycle rule is used for transitioning the object from one storage class to another storage class automatically. Or let's say if you permanently want to delete that object, you can set the lifecycle action. Okay. Configure S3 select on a schedule to invoke the Lambda function. When we have this feature automatically available, why we will schedule S3 select to invoke the Lambda function. And also S3 select is used to filter the subset of data using the structured query languages. That is the purpose of S3 select. Okay. Option D, storage length. So you can use storage length to gain visibility into S3 uses and trend. And here the use case is altogether different. Okay. So I hope this discussion was useful. Again, I will keep my discussion till here. I will see you all in the next video where I am going to discuss the further questions related to this official practice exam. Again, looking forward eagerly for your comments in the comment section if you want me to come out with the next such videos. Thank you very much for now. Have a great day ahead.